Welcome to a Monday. It's mid-morning right about now. This is Levi Stadium. We are going to talk a little bit about the ball game yesterday and how the wind had an impact on the balls being kicked. That's because it was pretty breezy at the stadium, but I want to show you something that I've learned about atmospherics in stadiums atmospherics. This low pressure, though, this is the story this week. It is going to set us up with basically an inversion that's deep. It'll shrink down at times, like on Tuesday, but it's going to move around a lot. And like right now, it's so deep that because of this low, that there is essentially no inversion showing down at Fort Ord. And that tells us that the atmosphere is mixing vertically. It's going to be a mild to cool day, below average temperatures in many locations, certainly the Central Valley. And then this low forecast, we'll see that coming up too, forecast to last through the week and intensify on the weekend, which would mean the potential for a few, maybe scattered showers, but mainly north, maybe some drizzle in Marin County. We'll see. That's on Friday night into Saturday. Okay, Levi Stadium. It was a good game yesterday. And I say that preseason's funny because it's not always the best ball, but they played pretty well. All the backups played really well. Jake Haener, Julie's son, was playing for New Orleans. That's one of the reasons we went. He played well, I thought. Then the backup 49er quarterbacks played well. Rattler played well. But what I noticed was I was here with my lovely daughter and wife, and we were sitting down here. First thing on preseason games, you get pretty cheap tickets, so you get good seats. Place was packed, good, really nice people. The winds were blowing out this way around the stadium. They're blowing sustained. It looked like 25 miles an hour. Flags were right up in here. So one of the things that I've learned about stadiums, because we've done this a long time, we work with Major League Baseball on wind flow and stadium atmospherics. We have all the Major League ballparks, and we're working with the 49ers right now. But one of the things we've learned is something called barrier effect. When the winds are blowing like this over the top, they blow pretty aggressively, right? Because they're not hitting anything. It's laminar above the stadium lip. But when you get lower to the stadium, you start bumping into solid objects. And when you bump into solid objects, the wind starts to curve. It refracts. Like waves do the same thing, point waves. When they come around a point, they hit the point. Have you ever seen that? And they bend in. The wave will bend in because it's hitting shallow water. Well, it's slowing, the shallow water, the bottom of the ocean is slowing that wave. Well, this scoreboard and this top of the stands are slowing the wind speed and making it rotate and shear, so it's spinning now, and it makes it sink like a curveball, perhaps, right? If you ever know much about baseball, curveballs have a tendency to, right? It's the same idea. It's not quite the same dynamics. Curveballs work on Magnus force, which is the force of the air hitting the thread. This is a barrier effect, which is actually just the wind hitting the wall. So either way, I was watching them kick, especially in warm-ups. And it was fascinating because the balls would get up there and they would carry a little bit. And I suspect it's because there's a little bit of flow through this gap. These asymmetric stadiums create more turbulence. So you have more. In the old days, stadiums weren't asymmetric. They didn't have cutouts like that. They were round. Well, these asymmetric stadiums have all sorts of intricate wind flow. And almost all stadiums now, especially the new ones, are asymmetric. Well, either way. Watching that, I realized, I'd seen it. We knew this at Oakland has the same thing, but the barrier effect. So whenever you're at a stadium, even if you're betting on a ball game, and you want to know, like a stadium like this, if the wind's coming into center field where most of the balls get hit and it's sinking, it's going to be a low-scoring game. So you bet the under, right? I mean, I'm not a gambler, but I just know this equates to play on the field, these different dynamics. So we'll get into that some other time, but I just thought it was interesting. It was fun watching, and we learned this at Oakland too. That at Oakland, the wind right field, which almost all the time in right field in Oakland because of the northwest prevailing winds, almost all the time right field is dead. We told Oakland about that, and they started pitching away from right field or towards right field when they were pitching, and they started having their hitters hit away from right field on certain days, on certain wind speeds. Okay. This is the low pressure. It's very similar to what we experienced last week. It's going to hang on, and it's going to deliver temperatures like these in the Bay Area. So I like it. Oakland 76 is almost perfect. Livermore 81 degrees. Central Valley low 90s. Up in Redding and Red Bluff. Chico 91. That's perfect. Up in Bidwell Park, 4 Mile. Sacramento out on the river 93 degrees. It's almost people probably in Reading, I'm just guessing, that in the evening when it gets down to like 75, they probably put on jackets. I'm just saying, because they're so used to the heat there. And it is typically pretty hot. So these are the 5-day figures, and you can see that we've got, pretty warm on Tuesday, but it's still at average. And then right here, temperatures really start to fall off, and especially as we go into the weekend. So we have a really nice weather pattern that is going to take fire danger and keep it off of the front page this week. It should. Air quality is going to be better. Smoke, not an issue. As we look at these live pictures, or this satellite, this was taken about 10 minutes ago. But you can see, let's see, there's a fire. This is up in Idaho, up near Boise. There's the Boise fire, which is up here, which you can't even see anymore. And there's a fire down here towards east of Fresno, which you can see right here. And you see a little bit of fog down around Santa Barbara, Point Conception. But the fog is having a tough time. It's this low is affecting the entire West Coast. So as you go further north too, you see that the clouds are up there. There might even be a little bit of rain in far northern or southern Oregon. This is the low. You can kind of see the curly Q. It's like a cinnamon roll, kind of. To me, it does, because I love cinnamon rolls. But that's the reason, and it's going to stay there in one iteration or another, in one form or another. It's going to be, well, we'll see it right here. Let's see if I can back this up. So right here, see, that's, if you can keep your eyes on California, can you see the cutouts? Okay, so this is a computer model. This is the GFS, vorticity. So I just like the colors because it's easy to see the upper level flow. The reds would represent a lot of vertical velocity, more so. In the oranges, that's representing air that's rising, unstable air. So relatively unstable. So there's the low. Here we are into Tuesday. You see where we are, right? Here we are right there. We're into Tuesday. And then look at that drop in. This is the piece right here. This happens on Wednesday, Thursday, and that into Friday. And that's significant. Whatever that is, that's certainly cooler, but also potential for some showers, some sprinkles. So watch this week, especially after Wednesday. It'll be interesting to see what happens. And then we ridge out after that. You see where we are, and you see that kind of clear sky. That's areas of air that's sinking, negative vorticity advection. If you're looking at this map, we're at 500 millibars, but we're just making it simple. And then you see a little bit of subtropical moisture, and then look at that. That's on September 2nd. That's an interesting pattern too. Again, long-range models, what are you going to do with them? They're not always right, but oftentimes they get you close to where you want to be. Okay, so here is Ocean Beach in San Francisco. Sun's trying to come out right now. We can go to Mavericks where the sun is out. There's Boneyards, the inside. Mavericks when it's surfable. Let's see if I can pull that up. There, it's moving. So when it's surfable, the wave breaks way out here. And then this is Boneyards where you don't want to get caught inside. And it's a beautiful day. I mean, look at the water and the sea surface texture. So that's Mavericks. That's off Pillar Point. This is Steamer's Lane, which is off Santa Cruz. And I was talking about refracting. This is the kind of place that you can get refraction around a point. So this is a great wave because the swells come in from the northwest. They shallow out here and they start to turn. And they run up the point. And when they run up the point, this wave, it's not a standing wave, but it's a wave that continues to rebuild. And then I've had waves at Steamer's Lane. You can see some of the surfers out here. I've had waves at Steamer's Lane that go for quarter mile, maybe even more. So these guys this is called the slot in here. When the tide's right, you can catch waves in there. And then we go down to Oceanside, and you can see just a beautiful, beautiful day. So it's a nice pattern for us. I hope it all works out for you. So we talked about stadium atmospherics, talked about refraction, barrier effect, and we talked about this low that is going to hang on, stay put, lessen the fire danger, help with air quality a lot. So if you're bothered by air quality, bad air quality, and we'll just no heat issues. Shouldn't have any heat issues. So it's good stuff. All right, we'll see you back here tomorrow.